For example 2, it says find the local maximum and or minimum values of f of x is equal to 1 plus the square root of 1 minus x. Well, the domain I'm going to pull from the radical there. And I know that 1 minus x has to be greater than or equal to 0, which means that negative x has to be greater than or equal to negative 1, which means that x has to be less than or equal to 1, where xer. For step 2, we're going to derive it. F prime of x. Now, I'm probably going to rewrite this function, f of x is equal to 1 plus bracket 1 minus x to the 1/2. Now that 1 is just going to become a 0, but the 1 minus x to the power of 1/2, I got to use that chain rule, 1 over 2, and 1 minus x to the power of negative 1/2 multiplied by 1. Or negative 1/2, 1 minus x to the negative 1/2, which is, when I move it down to the denominator, just negative 1 over 2 and the square root of 1 minus x. For the critical numbers, if 2 and the square root of 1 minus x is equal to 0, then when I solve it, x is equal to 1. And this, fitting into the domain, is when x has to be less than or equal to 1, which does fit into that domain. Then I'm going to go into my first derivative test. Now we know that x has to be less than or equal to 1, which means that, reasonably speaking, this region does not actually exist. I'm going to put in my test point. If it is less than 1, I'm probably just going to use 0. And then when I put that into my derivative and check my test point, then I get f prime of x is negative, which means that f of x is only decreasing. Because there is no change from decreasing to increasing or increasing to decreasing, f of x is always decreasing so there is no local minimum or maximum values. If I graph this out, then I'm going to wind up where it has an endpoint here, at 1 and 1, and then it's going to be quadratic that looks like this. So it does have a absolute minimum value of 1 at x is equal to 1, but that is at an endpoint. So when it says, is this function differentiable over its entire domain? No. Not differentiable at endpoint.